和组织科学基金会共同举办的第6期联合培训。首先，我谨在此代表北京工商大学对塔耶比教授就任经济组织科学基金会主席表示热烈祝贺。2020年，北京工商大学与经济合作组织科学基金会在中国科协“一带一路”合作联合培训中心，至今呢，我们已经组织了6期联合培训。我还记得在上一次联合培训上也致了一个词，这些联合培训啊，为国际交流提供了重要平台，汇聚了国内外专家学者资源。特别感谢我们的合作伙伴经济合作组织科学基金会一直以来的鼎力支持。塔耶比主席是伊朗知名的国际经济学家，在国际合作中具有丰富的经验。相信在塔耶比主席的支持下，未来联合培训中心的建设发展也将取得更多的成果。北京工商大学具有72年的办学历史，是北京市重点建设的高水平研究型大学。目前学校已基本形成了以商科、轻工和食品为特色的学科格局，也期待塔耶比主席未来能推动我校与伊朗、巴基斯坦及经济合作组织成员国在相关学科领域的交流合作。今天是塔耶比主席任职以来我们联合举行的第1次培训。在去年7月我们举办的第2期联合培训上，专家们介绍了中国新能源汽车产业及技术的发展，在国内外备受好评。新能源汽车的核心为3电系统，即电池、电机、电，其中电池系统占了新能源汽车成本的40%左右，是最为核心的部件。无论从价值量上还是从技术壁垒上来看，电池在新能源车的发展过程中都扮演了举足轻重的角色。而全球前10大动力电池供应商中，中国企业数量占了1半，具有明显的竞争优势。因此，我们应经济合作组织科学基金会提议，举办这期锂电池主题的培训，介绍中国及全球锂电池行业的发展。今天的5位专家将从锂电池的全球产业链、国际竞争格局、电池制造、电池大数据管理以及“一带一路”锂电池市场潜力等方面进行精彩的授课。期待大家在此次培训中就如何推动锂电池产业发展开展务实交流。最后，再次感谢大家的积极参与。北京工商大学将在“一带一路”倡议下持续推动与各国的交流合作，推动“一带一路”高质量可持续的发展。请大家持续关注和支持我们的各项工作，也期待未来有更多的科技工作者和青年学者加入到我们的交流合作中来，携手落实全球发展倡议，推动全球可持续发展。预祝此次培训取得圆满成功，谢谢大家。
Nada kali. Tayo session le bagay ke anji. Ya. Dada session le dada pu tano da main yo.
开始了。你听声音。行。
Untitled Information Development Company engaged many international investigations and research and large-scale market conferences organization. So for now, welcome Mrs. Xi to giving her lecture to us. Thank you.
Oh, sure. Okay. Thank you. Thank you. Yeah. Let me share the screen. Okay. 是这样的。Okay. Yeah. Good afternoon, ladies and gentlemen. It's my pleasure to take part in the event of Powering the Belt and Road with Lithium-ion batteries. The topic of my presentation today is Overview and Outlook for Global Battery Metals Industry. Yeah. There are 5 parts of the presentation. First is background. The second part is the proportion of global EV in industry to the battery metals. The third is the overview of global battery metals market. And the fourth is general characteristics of battery metals industry. And the last part is suggestion to BRI countries and some Q&A. This slide is the brief introduction of myself, just now the host has said. And this slide is the brief introduction of Beijing Antec, the company I now worked for. Antec is a consulting company and the CNIA with the government background. And Antec mainly provides the information and consultants services to government, both domestic and foreign companies among the metal and mining industries. And also we organize some large-scale event every year. And Antec undertake the ordinary works of CNI Cobalt branch and the nickel branch. Now, Cobalt branch and the nickel branch are the several organizations of Chinese nickel and cobalt companies. Now, let's see the second part, the proportion of global EV industry to the battery metals. As we know, the lithium-ion and batteries today are poised to become the preferred choice for many applications across the electric mobility, grid storage, and consumer electronics. The development of EV industry have brought and will bring great changes to the upstream raw materials, such as nickel, cobalt, and lithium. So-called we call the lithium, cobalt, and nickel as the battery metals. So in this part, we will discuss the proportion of global EV industry to the battery metals. This slide shows the flow sheet from ore to EV. We can see that the first step is we mining some ores, then make some concentrate, brines, MHP. That's the mixed intermediate nickel intermediate products. HMI, that's kind of a cobalt intermediate, and matte and scraps. We use these all materials, primary material and recycled material, to produce salts and precursors. For example, nickel sulfate, cobalt sulfate, and lithium carbonate. And then we produce the cathode materials, some for example, LFP, NCM, and then we use some cathode materials and other anode materials, some other additives to produce power battery, and then equip the EV facility. accounts that of the EV. The materials accounts for nearly 40% of power battery in vehicle aero. Mining and mining have been unprecedentedly. As I said before, NEV has become the common trend in global automobile industry. The United States, Europe, and China, and other countries and regions have introduced the policies and the measures to promote the new EV industry development. According to the Market Alliance statistics, the global NEV sales amounted to 6.52 million units in 2021, up 108% year-on-year, with the penetration rate growing from 4.2% in 2020 to 8.3% in 2021. According to China Association of Automobile Manufacturers, Chinese new energy vehicle sales amounted to 3.52 million units in last year, up by 1.6 times year-on-year. So ranking the first in the world for 7 consecutive years. According to the IEA statistics, based on the prediction of global NEV sales of 34.25 million units in 2030, the installed battery capacity will reach 3,000 gigawatts. The rapid development of NEV means for great demand for upstream raw materials, including nickel, cobalt, and lithium. Based on the NEV sales of 6.52 million units in last year, and the installed battery capacity is 292.1 gigawatts. The consumption of nickel, cobalt, and lithium were 147,000 tons, 33,000 tons, and 175,000 tons LCE respectively. Therefore, in 2030, the global nickel consumption in NEV sector is predicted to reach 1.64 million tons, with the CAGR from 2021 to 2030 is 31%. And the cobalt consumption will reach 240,000 tons in 2030, with the CAGR of 27%. And the lithium consumption will reach 315,000 tons, with CAGR will 29%. It should be noticed that all the calculation here is based on the total metal amount concept, which means the nickel and cobalt and the lithium consumption in NEV sector includes both from primary material and those from recycled scraps material. This slide shows the global cathode material output from 2017 to 2030. As we know, there are 4 types of cathode materials at present for lithium batteries. There are LCO, lithium cobaltate, and LMO, lithium manganite, and LFP and NCM. The global cathode materials output in 2017 was only 373,000 tons. This number growing to 1.35 million tons last year, with the CAGR of 38%. It is estimated that the cathode material output will reach 9.3 million tons in 2030, with CAGR over 20% in next 10 years. NCM and LFP are accounted for majority of the market shares. Last year, from the global view, the NCM cathode material accounted almost 50%, and LFP accounted for 35%. Most of them are used in power batteries and ESS facilities, and will increasing fast in the future. And for the LCO, that's lithium carbonate, and is mainly used in traditional 3C field. That means computer, some mobile phone, and some small-scaled iPad, something like this. And the lithium magnetite is used in electric bicycles and small-scaled energy storage facilities. Both of them will keep moderate growth rate in the future. And this slide shows the cathode material output by country. We can see which country is the pillar of the cathode material producer. We can see that from the global cathode materials output is mainly in China, Japan, and Korea. And China is the biggest producer in the world, accounting for 77% last year. Most of the cathode materials produced by China companies. That's the second part. Now we turn to the third part. This part is the overview of global battery metal market. Generally saying, the battery metal will refer to lithium, nickel, cobalt, and lithium. First, let's see the nickel market. The nickel market. Last year, the nickel reserve from the global view is about 95 million tons. We can see that Indonesia and Australia are the two main nickel reserve countries in the world. Especially Indonesia is an emerging nickel reserve country in the world. Before Australia, before 2014, Australia is the number one. And the next picture is the global nickel mine output. Last year is about 2.7 million tons in the world, and we can see that Indonesia is the leading producers in the world, following by the Philippines. And some traditional nickel producing countries, for example, Russia and Canada, now ranked the fourth and the third. China only account for 4%. And this slide shows the global MHP production. MHP is a kind of intermediate products especially from nickel laterite. Then use MHP to produce nickel sulfide or some electrolytic nickel. Last year, the global nickel MHP output is about 267,000 tons. And we can see that also the number one is Indonesia, and the second is Philippines, and then Australia, then Cuba and Papua New Guinea. So we can see that in recent years, Indonesia play great roles in the world nickel market. And the global in right is the nickel consumption breakdown. The total global consumption last year is about 2.77 million tons. And stainless steel is the #1 consumption field. And then followed by battery sector is 12%. And then electroplating and some alloys and casting and others. So stainless steel now is still the pillar of the nickel consumption. Yeah. This slide shows the global primary nickel output. We can see that last year, the primary nickel output is 2.6 million tons, and will continue in this year. From the global view, the primary nickel output increased year by year in recent years. And this year, because of large amount of new project put into production in Indonesia, the world primary nickel output will increase by 20%. And China and Indonesia are the leading nickel players in the world. Last year, Indonesia exceeded China to become the #1 primary nickel producing countries in the world. Before, since 2009, China exceeded Russia to become the #1 of the world primary nickel producing country. But last year, Indonesia exceeded China. Now let's come to cobalt. First is the cobalt reserve. In last year, the global cobalt reserve summed to be 7.6 million tons, of which, as we know, DRC Congo accounts for 50% of the global cobalt reserve, and then Australia 20%, and Cuba 7%. Most of the cobalt reserve is in DRC and Australia. And from the perspective of cobalt mine output, also DRC is the #1. Last year, the global cobalt mine output is nearly 160,000 tons. It is estimated this year this part of the cobalt mine output will continue to increase because some new project in DRC also expand their capacity this year and set up to production. And this slide shows the global refined cobalt output and consumption. Last year, the global refined cobalt output grew by 10% to about 167,000 tons, with majority of the increment comes from China. And last year, the cobalt consumption grew by 18%, a large amount of increment last year. The total cobalt consumption last year is about 166,000 tons. And the consumption of lithium-ion battery accounts for about 67%. And the cobalt consumption increased as high temperature alloys and hard alloys industries against the restoration. This slide shows the global lithium reserve and lithium mine output. According to the data from USGS, in last year, the global lithium reserve is 22 million tons. This means that lithium content, not LCE. Most of which distributed in Australia, Chile, Argentina, and China. We can see that Chile accounts for 41%, then Australia 25%, that's the Argentina 10%, and China 7%. In the future, maybe in Zimbabwe and some other countries, for example, DRC, also we found some lithium reserve in these countries. As for the global lithium mine output, we can see that last year, the global lithium mine output is about 571,000 tons, increasing by 41%. This growth rate is very fast, but compared with the, how to say, much faster growth rate in the downstream sectors, for example, EV power battery sector last year increased by maybe 100%, and for the EV sector last year increased by 160%. So even the lithium mine output increased fast, but still slower than the downstream. This slide shows the global lithium salt output and consumption. Last year, the total lithium salt output is about 604,000 tons. The unit is LCE, lithium carbonate. And China is the large, although China, the reserve is not so rich, but the lithium salt output, China accounts for 70%, and then Chile accounts for 23%. Argentina is 5%. As for the global lithium consumption, we can see that from the by country comparison, we can see that the last year, the global lithium consumption is about 575,000 tons, and China accounts for 73%, and South Korea and 12%, and Japan 7%. We can see that most of the lithium salts consumed in Asia countries. And this slide shows the cobalt consumption breakdown by fields and the lithium consumption breakdown. We can see that for lithium and cobalt, there are some, how to say, similar for these two metals. Most of the lithium and most of the cobalt are consumed in lithium sectors. For cobalt, about 70%, and for lithium, about 74%. But for nickel, just now I said only 12%. So we think the cobalt and the lithium are more sensitive to the development of battery industry. That's the third part. Next, let's turn to the fourth part, the general characteristics of battery metals industry. We summarize some how to say, some characteristics from the global view. First, we think for the battery sector metals industry, one point is major economies attached importance to battery metals minerals. As we know, in the United States last year, the US released the 2021 to 2030 blueprint for lithium battery development. In this report, we can see that the United States wish to extraction the critical minerals and the refined materials, as well as alternative for commercial and military uses, and enhance the support for US materials processing plant to satisfy the domestic demand and stimulating the production lines development of electrodes, batteries, and fabrications, and securing the mass recycling of critical materials and advantage in the whole industry chain. And for the critical materials, all the nickel, cobalt, and lithium are listed in critical materials of United States. And also in United States, last year in June, the White House published 100-day reviews on building resilient supply chains, but also strengthened to support lithium extraction in the US and support nickel and cobalt recycling in the US, and investing the nickel refinery and in allied countries, for example, in Australia, and support the sustainable cobalt development. And last year, in South Korea, also published a 2030 key battery development strategy. In this report, South Korea wish to build a stable supply chain of secondary battery materials, strengthening the acquisition of overseas mineral resources, and improve the reserve systems through government to private corporations, and expand the application of recycled materials to meet the domestic demand for electric vehicles. And they want to, they want to considering the expanding the reserve of rare earth metals, expanding the reserve of cobalt, and spices of supply and demand concern by 2 to 3 times, and improve the utilization strategy according to the supply and the demand situation. And the second is the battery metals gains rapid growth rate despite the slowdown in other fields. Since the outbreak of the COVID-19 pandemic, the global demand for energy resources has shrunk in general, and the structure has been differentiated, with energy and bulk mineral consumption decline, while the new energy minerals, for example, cobalt, nickel, and lithium consumption growing fast. In 2020, the total global energy consumption declined by 4.5%, and the largest decline since the World War II. And oil, coal, and natural gas consumption declined by 9.5% and 3.9% and 2.1% respectively. But in the other side, wind power, hydropower, solar, and other renewable energy grew by 9.7%. The iron and aluminum consumption fell by 0.2 and 0.7 respectively. But the copper, lithium, and cobalt consumption grew by 6.2%, 15.3%, and 7.3% respectively. The third is battery materials resources are unevenly distributed, and China is a major imported country. As we know, the distribution of global battery metals resources is very uneven. DRC have the world's largest number of high-quality reserve of copper and cobalt. And Indonesia accounts for 22% of global nickel reserve. And the South American lithium triangle accounts for 56% of global lithium reserve and 22.7% of global copper reserve. From the demand side, we can see that the global manufacturing industry is concentrated in East Asia, Europe, and North America. The bulk exports from Australia, Chile, Brazil, and other resources countries, and the strong reliance on imports of East Asia, Europe, and North America can constitute the basic pattern of the international metal and mineral trade flow. And China is the largest manufacturing country and also the world's largest importer of metal minerals, occupying an extremely important position in the international bulk metal mineral market. Last year, China also imported about 300,000 of hydrometallurgical cobalt intermediates and about 43.54 million tons of nickel ore, especially mainly from the Philippines, and 2 million tons of lithium concentrate, most of them from Australia, and all ranking the first in the world. Okay. And the fourth, that global mineral exploration and merger and acquisition increased in recent years, among which many were about lithium and rare earth minerals. According to the statistics of S&P Global Market Intelligence Survey of 1,948 mining companies with exploration budget over $100,000 US. The sum for these companies in non-ferrous metals exploration budget amounted to $11.2 billion US in 2021, in last year, an increase of 35% from 2020. It is expected that the total global exploration budget will increase by 5% to 50% in this year. And in last year, the merger and acquisition for lithium mining companies grew from $76 billion US to about $3.6 billion US, an increase of 46 times. And mining companies, copper and lithium, cobalt, nickel, and other new energy minerals. And in this stage, in this period, most Chinese companies play the major roles in the world. Yeah. The five characteristics is that for the recycling, being able to be recycled is another major difference of battery metals from the traditional energy minerals, such as oil and coal. Almost every country in the world attached great importance to cobalt recycling, and the recycled material constitutes about 15% of the global refined cobalt production. And this percentage will, increase, lift to 25% in 2025. And the recycling of nickel is very important because in stainless steel scraps and high temperature alloy scraps have been thriving in the recycled usage. and the recycled process of battery scraps become more standard in recent years. And also, the volume of recycled lithium is growing in recent years, especially in China. As we know, the European Union has published the European Union battery regulation. There are further requirements for its raw material source. Till 2030, the proportion of recycled materials used for cobalt, lead, lithium, and nickel production should reach cobalt is 12%. That's for lead is 85%. For lithium is 4%. For nickel is above 4%. At present, for most of the Chinese companies, they can reach this standard at present. Yeah. Just now, I give a rough comment about the battery and metals market and some characteristics from global view. Now let's turn to the last part, is some suggestion and Q&A. Yeah. I have for this topic, I'm sorry, I haven't visited the Central Asia countries before, so I'm sorry to give any practical suggestions for the Central Asia countries. Let's see what's the role of Central Asia countries will play in lithium battery industry chain. What we can do. First, let's from the reserve. Just now, we analyze the reserve and the resources from global view, and the mining and smelting. From the mining and smelting the sector, China companies play important roles in the world. Just now, I mentioned for example for lithium, China account for about 70% of the global lithium salt industry. And for cathode materials, also Chinese companies are the major players. Now Chinese output account for about 70%. And for power battery sector also account for 50%. So if we say at present, we are not ready to deal with the business from the processing from ore to battery. Let's see what's the market size in the Central Asia countries, in BRI countries. Here. This slide shows the car sales volume comparison between Central Asia countries and ASEAN countries. ASEAN is another important region for BRI countries, and I have, because of I studied nickel for many years, and I have been visited Indonesia and the Philippines for several times. So we can see from this picture that every year the car sales volume in Central Asia countries is lower than in ASEAN countries, and the biggest is Uzbekistan. The total volume is about 203,000 units per year. The similar level with the Philippines and Vietnam. That's the car sales volume comparison. And this slide is the car ownership comparison between Central Asia and ASEAN. That would be per thousand person. from this level, we can see that the rather high level for in Central Asia country is Kazakhstan and Kyrgyzstan. That is respective the 253 unit and 215 unit for this country. This level is similar with the Thailand and Singapore, and also China. For the average, the car ownership per 1,000 person, China is 215. That's the similar in these countries. It seems that from this comparison, we can see that it seems that there are big rooms to promote both the traditional ICE cars and EV cars in central countries and in some BRI countries in the future. And at last, I would like to give some suggestion for the development of in new EV era in this period. One is the strengthening the exploration for battery minerals, especially for lithium. Later, I'll explain why lithium is more important. And the second, I think my suggestion is if there is a possibility, these BRI countries will carry on the industry chain transfer. For example, the nickel stainless steel industry now transfer to Indonesia and Eastern, some battery and cathode material transfer to Eastern Europe. And the third is speeding up the piece of electrification, taking the initiative to embrace the future. And why the lithium is more important, I think, for nickel, cobalt, and some other minerals, for copper, some aluminum, we have to do more exploration works before. Lithium is a new emerging minerals, especially now there are some deficit from supply and exploration. So we wish in the future the BRI countries pay more attention in lithium exploration to meet the rapid demand growth rate. That's all for the presentation, and maybe in the next at the end of this event there's some questions and a discussion. I would like to join. Thank you. Yeah, you see now. Okay.
Okay, so thank you, Mrs. Shi. Okay, it is just technology programs. Anyway, thank you, Mrs. Shi. So our next picture, it's Hongmu-nan. I'm so sorry, just a minute. We fixed out the technical problem.
Okay. All right. Okay. So our next guest is Hongmu-nan. Mr. Hong received his BE and PhD in the Department of Vehicle and Mobility, Tsinghua University, China in the 2005 and 2010. Respectively, from the 2005 to 2010, his research focused on a mobile-based hybrid powertrain system control. He works as a visiting fellow in the Department of Engineering and Applied Sophia University, Tokyo, Japan in 2008. He used to be a chief engineer of factory system in the Chang'an Automobile Corporations. Now he's worked in Ruilian Wuyou Technology Corporations. His research interests included battery system design and terminal cloud cooperative battery management. He has participated a series of projects of battery management and battery systems and obtained Chongqing City SNT Programs Award and SAE China SNT Programs Award. 2020 SAE Environmental Excellence in the Transportation Award. Okay, so let's welcome Mr. Hong.
好，谢谢主持人的介绍啊。共享一下。
有这情况？
有。
稍等一下，我这好像共享有点问题。能看到我的屏幕吗？
可以看到。
好，不好意思啊。大家下午好。我是瑞理物联的这个联合创始人洪木兰。那么大家知道哈，云计算、大数据和人工智能等技术在各行各业得到了广泛的应用。这些技术呢，也同样逐步应用在了锂电的能源领域。那么今天我要和大家分享的就是基于大数据的云控电池管理系统。锂电池的应用呢，在各个领域已经取得了高速的增长，现在已经进入了 T 瓦时的时代。去年全球的锂电出货量达到了562.4 G 瓦时，那么其中呢，中国占比60%左右。尤其是在交通的电气化和电化学存储上的应用增长十分迅速。太阳能、风能、潮汐能、生物能等等这样的一些清洁能源的发电发出来的电是没有办法实时消耗掉的，需要存储下来。交通领域的这个新能源汽车也需要移动的储能装置。电化学储能是未来最广泛的储能方式。锂离子电池呢是最合适的能源载体。右边这张图呢是中国锂电出货量的这个历年数据和未来的预测。可见呢，动力电池占的比重是非常大的。那个橙色的是动力电池，然后那个灰白色的是储能电池。我们可以看到，在接下来的几年里它们还会保持较快的增长速度。但是呢，随着锂电池应用规模的提升，电池的安全事故越来越多，严重威胁了产业的发展。那么去年的锂电池火灾数量 和2020年相比增长了160%。那么我们可以看一些这个具体的这个案例，在19年4月21号啊，这一辆电动车起火，引燃了这个旁边的车辆，造成了大量的这个财产的损失。这是一个比较残酷的一个案例哈。那么同样的，在那个第二个案例呢，是一个储能电站发生了着火，引发了爆炸。那么第3个案例，2022年4月19号，一个电动车换电站起火，引发了火灾。那么不仅仅是这个大的动力电池有安全风险，小动力电池，比方说用在这个电动自行车上的，一样的有安全问题。那么右边最上面这个呢，是停在自行车棚里的电动自行车着火，引燃的车棚。那么下面这个呢，是一块这个电动自行车电池在路边着火了。那么拿这个灭火器去灭火，但是非常难扑灭。可以看到这个火起来之后非常的困难，就是这个灭火非常的困难。这是因为电池的内部发生了非常剧烈的化学反应，短时间内持续释放大量的这个化学的反应热，那么只能通过喷洒大量的水来进行冷却，来灭火。那么除了这个安全问题之外，动力电池的容量衰减没有办法在满足我们这个电动汽车的使用要求之后，是可以退下来，在小动力电池领域，比方说这个电动自行车领域继续使用的。那么也可以作为储能电站的这个储能电池使用，这就是电池的梯次利用。那么梯次利用的电池，如果还是再往下无法再利用了，那么可以报废拆解，把其中的关键材料回收，这就是电池的全生命周期的使用过程。那么在这个过程当中呢，存在一些技术难点需要去克服的一个是怎么去有效的降低电池的安全隐患第二个呢，怎么去提升电池的这个资产的保值率第三个呢，怎么去精准的定位这个问题的所在。那么第4个，快速评估退役电池的这个剩余价值。第5个，要去准确的评估电池的这个劣化的程度。那么最后还需要在这个全生命周期的使用过程当中，为用户提供更优质的这个能源服务。那么大家都知道，BMS 就是这个 Battery Management System， 它是这个管理电池的安全的一个核心部件。但是目前的新能源汽车行业已经证明了现有的这个嵌入式 BMS 不能够彻底的解决电池系统的安全问题主要是由于开发周期短，电池的性能测试不充分，传统的 BMS 算法难以在电池的严重衰减后保持良好的精度，并且对电池进行有效的安全管理。另外呢，电池的缺陷引起的热失控的这个特性 比较难在开发阶段去捕获到，那么更难以被这个 BMS 的诊断算法覆盖到。而且呢，在梯式利用的场景，传统的 BMS 也是没办法做到对这个有严重的一致性问题的这个电芯进行准确的标定和算法的保护，这就使得流入梯式利用场景的这个电池啊，它的安全性是更差的。云控电池管理呢，可以在一定程度上解决这些问题啊。一方面，对于电池产品的天生缺陷，比如金属颗粒的杂质连接件的松动，还有像采样线的松动，就电压采样线的松动，极片的错位、隔膜的破损等等。那么这些呢，是可以借助大数据和云平台的这个计算能力，来开发电芯的安全预警策略和系统的故障诊断策略，来完善BMS 无法实现的故障诊断和预警功能。那么另一方面呢，针对工况复杂、电池的使用和管理不当的问题，可以通过云控电池管理来识别工况，并自动匹配，在平台上计算呢更适合的控制参数，并且下发到本地的这个 BMS 中，实现安全控制参数的远程修正，以及对电池电量估计的修正，对电池容量估计的修正，对这个热管理参数的修正，对均衡控制的修正，以及包括一些这个电池的基础标定的修正等等。也就是说，对于电池天生的这个质量缺陷、设计缺陷以及复杂应用场景带来的这个滥用、误用、不及时维护不及时等等这些问题，可以通过大数据和云计算加以弥补，在云端进行长周期、大规模的数据分析，实现小概率安全失效过程的捕捉、建模和诊断算法的开发，并通过下行控制来实现 BMS 的控制算法实时优化。这就是我们云控电池管理系统的构架主要由3个部分组成，分别是这个传统的 BMS 电池的数据模块，还有我们的云平台。那么通过传统的 BMS 来采集电池的电压、电流、温度等数据，并发送给电池的数据模块。电池数据模块呢，对数据进行一些压缩和预处理，然后再上传到云平台，利用平台服务器的超强算力和超量数据的存储能力，来运行高精度的先进的算法，实现电池的安全预警、故障报警，同时精确计算电池的剩余电量、可用容量等信息，并确定电池在当前老化状态下的最佳控制参数，下发给本地来执行。那么通过线上自动算出的预警和报警的结果，我们有专门的这个专家团队来进行确认，必要的时候将这个确认后的这个故障电池拉回来做检测、确认，并且加以维修。通过在车载端嵌入这个我们的电池的数据和数据的这个模块，可以对数据做封装，并且可以开发这个变频传输的算法就是它上传到平台的频率是可以变的，可以根据运行工况和场景来做这个频率的变化，解决了传统的数据传输频率一刀切。重要的数据呢，它上传的频率不够高，和一些次要的数据呢，又占用了过多的这个上传的资源，这样的一些问题。那么举个例子，电池放在那里没有使用的时候，通常 BMS 是没有处于上电状态的，这时候是采集不到数据的。那么我们可以通过主动的去把这个 BMS 唤醒，来主动的收集数据。那么这个对于安全监控是非常重要的。 第二个呢，我们要构建面向不同应用、具备自更新、自修正能力的精准的这个电池数字孪生模型。通过数字模型呢，能够计算出电池内部的状态数据，而这些数据呢是无法通过传感器测量得到的，比如内部的温度、内部的电位等等。我们甚至可以通过在数字模型注入一些这个异常来获取实际情况很难得到的数据，这样我们就会有真实的数据和一些虚拟的数据来组成一个增强的训练的这个数据集。有了电池的这个数据模块和云端的这个数字孪生模型，我们可用的这个数据量大大增加，包括原始的数据，还有预处理的这个数据，还有一些基于数字模型的内部的可视化数据，以及故障注入数据等等，我们可以抓取更多的数据特征，而这些丰富的数据信息和 AI 算法结合，可以取得更好的效果。那么这里列举了几种不同的算法，最基本的是这个阈值的超限，运行的范围超出了正常范围，这是比较容易检测的。那么还有一致性的异常内短路的检测、稀里的检测、寿命的预测等等。下面简单的做一些介绍。这个是一致性的异常，主要利用了电池的历史的运行数据，对动力电池外在的表现它的演变规律来提取特征指标并且对不同车辆的电池进行一个横向对比，利用数据挖掘算法来做这个故障报警。那么这个模块能够识别出电压异常、内阻异常等等一些潜在的故障。这是内短路检测的一个算法的一些基本的这个表现我们利用电池的运行数据和电池模型，将存在内短路可能造成电池热失控的异常电芯识别出来。那么这个模块呢，主要从电池的电压、温度等等一些这个实测的信号来提取热失控前期电池故障的特征信号，并且呢，基于多信号融合的方式呢，来判断内短路的严重程度，实现不同等级的这个安全预警。这个是稀里的检测主要是用来判别电池的内部是否存在稀里的情况，以及这个稀里的严重程度。那么它主要是通过可逆里的这个析出和嵌入过程的分析呢，来提取稀里电池的电信号特征。那么基于离线标定的这个定量稀里检测算法呢，我们可以去对这个电池的稀里情况呢做一些判断。那还有最后一个寿命预测我们利用电池的这些数据呢，还可以识别电池的老化状态和剩余的使用寿命。那我们这个算法呢，是从电池的历史的纵向数据这个时间维度上的纵向的数据和空间维度上的多个电池的横向的数据来做一些对比和分析，然后自动去给每个电池配这个寿命状态的标签，那么可以有效的解决我们常规算法没有训练数据标签的这个问题。那么这个是我们云控系统多重安全监控这个预警算法工作的一个实例我们可以看到，在2021年8月31号，我们第一次检测到了6号电芯发生了稀里。那么在10月30号检测到电池的某一个这个指数是异常的然后呢又发现它的置放电是异常的并且是跟别的电芯差异很大然后我们紧接着又发现它这个发生了内短路最终在这个10月31号9点半报出了这个热失控的报警信号。那么在半个小时之后，这个电池就发生了热失控。也就是说，我们这个电池在 发生热失控的2个月前就已经是有特征了。那么我们最终确认这个故障呢，是提前30分钟就把这个准确的故障报出来并且我们因为报出来了嘛，所以我们是通过我们的客服去联系这个客户，把这个电池是取出来，所以没有造成这个安全的事故。这是对另外一个监测出吸锂电池的一个案例那么同样的，我们是在这个发生这个电池是没有发生安全问题的我们是在8月份的时候发现它这个吸锂了然后后续多次发生了这个吸锂，而且这个电芯它的置放电也比较异常，同样也检测到内软路一些这个特征指标是比较异常的。然后我们觉得这个电池风险比较大，就把它调回来，在这个实验室里面去做测试通过核磁共振这样的一些这个仪器来确认了这个极片内部确实出现了明显的这个吸锂现象。那么还有许多的案例由于时间的原因就不一一介绍。那么我们通过建立这个特征工程创建 AI 模型并持续在这个实际案例当中验证迭代，不断更新我们的预警算法精度持续提升。在整个系统上线了1年多的这个时间里我们累计监控了35万组的电池成功预警和报警了6次电池的火灾。那么当然也有1次误报我们的预警时间平均都是在10分钟以上就是能够提前去做一些应急的处理。那么云控 BMS 除了可以做安全预警之外另外一个重要的应用是故障诊断。我们通过故障特征库对电池的故障进行了精细的分离和定位来预测故障发生的位置、准确的原因发生的时间和严重度，来直接指导我们电池的售后维护和资产的运维。那么这里背后的逻辑呢我们可以参考这个海恩里奇法则它这个法则是一个安全生产的法则它告诉我们每一起严重的事故背后必然有29起较轻微的事故和300起未遂先兆以及1000起事故隐患任何事故的发生都不是偶然的，都存在大量的安全的这个隐患。那么这个准则呢同样适用于锂电池的系统因此呢我们在发生这个严重故障之前，我们就尽可能的去识别电池的各种异常，提前处理，来规避后面发生严重的事故。这个呢就是基于我们的云控电池管理系统呢建立的智能运维的管理体系。首先呢通过我们前面的这些技术来进行相关故障的报警和预警，然后呢我们需要通过人工接入来把这个故障传递给我们的运维调度和管理平台，来进行相应的这个工单的派遣和地面的这个维护，联系用户进行更换或者是维修。那么我们这个系统呢目标呢是把电池的故障率降下来，把电池的这个维修的时间降下来这依赖于我们准确的识别问题快速的流转问题以及做一些预测性的维护我们的这个整个平台呢包括2个部分，一个是我们总部端的是用来做整个故障的一个监控、运行的监控和统计的分析等等。那么我们还有外勤端的，外勤端主要是给我们的运维人员做这个工单的接收还有这个往下流转这样的一些业务。我们目前持有这个1000多个的电动自行车的电池我们这个电池呢也是租赁给电动自行车的使用者 我们对这些电池使用了云控电池管理系统技术和我们的智能运维系统。那么电池运行过程当中会发生各种各样的问题，顾客会抱怨平台会报警，这时候呢就需要通过智能运维系统去识别和筛查哪些需要处理，哪些不需要处理，哪些需要紧急处理和优先处理，那么哪些可以是把优先级放低一点。这个就是我们采用，我们看右边这张图是我们平均处理一个问题的时间那么在1年的时间里，我们客服和运维的效率是逐步的得到提升，可见我们这个平台它的这个效果还是很明显的。那么这个是一个5维度的电池健康度的评估体系因为我们刚刚也提到了嘛，我们这个算法呢是可以去评估电池的健康度，它的这个剩余的价值剩余的寿命。那我们就是有这样的一个评估的体系，可以对电池包里头因为一个电池包它是由很多串电芯组成的嘛，那么我们可以对每一串电芯进行独立的多维度的和精准的健康度的评估，它可以实现准确的估计电池包内每个电芯间的这个一致性，以及每个电芯的容量衰减的状态，也可以估计电芯的置放电率计算每个电芯的这个内阻。我们根据大量电池的衰减数据进行了衰减诱因敏感度的分析和衰减机理的建模，通过最优化的控制方向来寻找最优的控制参数和工作区间再通过云控下发来优化这样的一些控制参数所以我们除了上行把数据上传，做安全预警，做故障诊断，做这个价值评估，做寿命预测我们还同时会往电池这个终端往车去发一些控制参数，实现这个应急的处置，比如说安全的应急处置，以及对这个本地管理策略的一个自适应的升级所以我们这个是双向的。那么最后再做一下小结锂离子电池呢，在移动端主要是我们的电动车另外一个在固定端主要是我们储能领域当然还有一些其他的领域得到了很多的应用。那么传统的 BMS 是无法满足所有的这个需求的，特别是整个电池全生命周期使用的这个需求。云控的电池管理呢是将来的一个方向，它其实不是替代现在的 BMS， 它是对现在的 BMS 的一个外拓和延展。那么通过这套系统呢，它可以用于早期的安全预警可以更加准确的定位故障的这个原因和更多的这个故障能够爆出来以及准确的预测电池的这个价值。我的这个分享就到这里，谢谢大家。
Okay, thank you, Mr. Hong, giving the excellent speech. For now, we're gonna have a 10-minute break. We're gonna have a 10-minute break.
有声音吗？没有没有。
Welcome back. Welcome back. And our next guest is Mr. Li Keyu. He is the Vice President of the Green Harbor Investment, a private equity investment fund focused on the intelligent driving, carbon neutral, and nickel technology. So industrials with the management size of over 6 billion yuan. Welcome, Mr. Li, to giving us a speech.
大家好，我叫Vincent，然后我是目前呢是一个新能源行业的一个投资人，我们基金呢关注新能源行业也已经比较久了，目前整体的在管规模差不多接近70亿元人民币，那么今天很高兴呢能有机会和大家就新能源行业的一些发展趋势以及相关的投资方向做一个交流和沟通。那我把我的这个 PPT， 那么首先呢，其实碳中和呢是目前全球各个国家达成共识并努力发展的这么一个方向。虽然近期呢，其实受到这个新冠疫情啊，然后也同时是包括这种乌俄战争的一些因素的影响，相关能源政策在欧洲等地其实出现了一些阶段性的一个调整，但我们可以看到大的趋势还是不可逆的。那么中国作为一个非常负责任的大国呢，我们也始终坚持能源结构的调整，提升清洁低碳能源的一个占比，然后也在为实现2023年前的这个碳达峰以及2026年前的这个碳中和而努力。那么以碳中和为目标，主要的途径呢有2种，一种呢就是减少碳排放，那么第二呢就是增加碳吸收。从产业层面更为有效以及切实可行的，主要还是在二氧化碳的这个减排方向。那么我们可以从供给和需求侧2个方面来看这个问题。首先，能源供给主要是从化石能源转化为更为清洁的电力能源和氢能，而需求侧在工业、建筑、交通等不同领域也在同步发展如何高效的应用这些清洁能源。目前最受关注的其实也就是这个标红的这里啊，一个是新能源汽车和这个智慧交通，然后另外就是一个是新能源汽车的一个推广吧，另外就是这个共享智慧交通的一个普及。那么新能源汽车和智慧交通分别从调整能源结构和节能减排的角度来助力我们实现这个碳中和的目标。目前呢，这2个赛道也是中国发展最快且潜力最大的市场之一。
你的那个播放一下，谢谢播放。
这样可以吗？能看到 PPT 吗？
在播放。
等一下，我这边，所以这边没有看到我共享的屏幕是吗？能够看到我这个播放的 PPT 吗？不好意思，刚才可能技术上面出了点问题。
可以看到屏幕，但是播放全屏没有办法看到。播放。
我这边因为我在我电脑上这边是已经播放了的，对，我这边已经是播放了，可能。
对。
因为我这边已经点了播放的这个选项，还是不可以是吗？
菜单栏里的放呢？
或者我们这边有没有其他人能够去放一下这个？因为我这边点了播放了，但是没有办法全屏。
可以，我们这边给您共享。可以吗？可以，现在可以吗？
我这边我们跟OK， 就是你们那边已经播放了是吗？哦，好的，我看到了，谢谢。那我继续啊，不好意思，有点技术问题。那么这张图其实是可以比较直观的展示整个新能源车的市场发展的一个预测吧。中国其实2022年的新能源车销量预计是可以突破500万辆的，这个发展速度非常的迅猛。主流的车企其实都在积极的去布局新的电车车型。预期到2030年呢，新能源车在全球的销量就将达到3800万辆，其中中国的占比超过40%。那对于整个中国市场来看的话，中国目前拥有全球最为完善的新能源汽车相关的产业链，其中动力电池领域拥有像宁德时代啊、比亚迪啊等全球出货量都位居前列的这么一种巨头公司。同时，中国政府在新能源汽车领域推出了一系列的这种促进行业发展的政策，就包括我们大家都比较熟知的这种减免购置税啊，然后包括购车补贴啊等等。即使在这种疫情的影响下，近几年中国的新能源汽车的销量仍旧增长非常的迅速。那么整体25%的这个渗透率的目标，其实将在2025年之前提前就实现。中国新能源汽车行业的发展也进一步加速和推动了海外和合资车企在中国市场的整电动化的一个转型。那么我们下一页，其实这里呢就是全球部分国家关于新能源车的一个相关的政策一个总结吧。目前来看的话，主流车企相对应的战略规划，我们可以看到，其实包括像英国呀、法国呀、德国啊、日本等等国家，都明确了一个非常具体的禁售燃油车的这么一个时间。这给新能源车以及动力电池的发展，其实带来了一个非常宝贵的机遇和时间窗口。那么我们可以看到，新能源汽车行业的发展作为实现碳中和目标的一个重要的路径吧，在全球范围内是形成了一种共识的。那么传统车企纷纷加速了电动化转型之路。尤其是中国呢，其实近几年来涌现了许多具备非常强竞争实力的造车新势力的公司，比如说我们大家都比较熟知的像蔚来啊、小鹏啊、理想等等。那么预计在未来的3到5年，其实整个的新能源汽车以及动力电池行业都将迎来行业发展的一个黄金时期。我们下一页。PPT 可以翻到下一页，谢谢。对，这一页呢，其实展示了动力电池装机量，就是随着这个新能源车发展而快速稳定提升的这么一个趋势。而在技术和产业层面，其实最核心的呢是2个方面，一个是电池性能的提升，另一方面就是成本的下降。具体的途径以及其实涉及很多的方面吧，就这里面包括像这种新的材料的应用啊，包括不同封装方式的应用，电池结构的调整等等。就比如说由液态电池向半固态以及固态电池的这么一个推进。宁德时代它其实选择重点研发这个钠离子电池，尝试这种新的材料，而比亚迪的刀片电池其实也就是传统的磷酸铁锂电池，但是它则是通过这种对电池形态的一个创新，去发挥这个磷酸铁锂电池成本低、安全性高的一个优势。但与此同时呢，进一步提升能量密度，缩小与3元锂电池之间的差距。而动力电池企业其实是新能源汽车产业链中最重要的一环吧。然后目前动力电池本身仍在不断的进行这个技术的更新和迭代。同时，随着这种风光储等行业的一个发展，进一步推动动力电池厂商发展储能相关的电池技术，也是目前的一个行业趋势。 下一页。其实与此同时，我们可以看到啊，就是主流的这种3元锂电池，包括磷酸铁锂电池，它们的电池有效寿命一般在5到7年左右。其实最早发展的那一波动力电池呢，也已经进入到了一个退役的浪潮，所以也就带来了就是电池回收成为了一个非常重要的市场。那么对于3元锂电池，其实它的寿命是更短的，而且电池容量的衰减也比较快，稳定性也比较差。但是呢，它里面用的这个原材料，像这个镍啊、钴啊、锂的价值都比较高，所以这种情况下呢，一般就采用这种直接拆解回收材料的一个方式。而磷酸铁锂电池呢，它因为相对来说这个寿命时间长一些，容量衰减慢一些，稳定性也比较高，所以它可能会采用一个先去进行梯次的利用，然后再进行拆解的这么一个方式。但是目前呢，其实动力电池的回收行业还处于一个行业发展比较早期的阶段，它的分解与回收的主流技术路线还在一个不断摸索和尝试的这么一个情况。但是可以明确的是，随着动力电池退役数量的增长，那么动力电池回收的市场也将产生巨大的一个市场的潜力。下一页，这一页可能会比较有意思一点啊，就是其实，对 PPT 可以翻到下一页。对，这一页比较有意思一点，因为这里列举了其实是一个核心技术的演进方向。就目前市场情况来看呢，磷酸铁锂电池它大概成本是可以低于3元锂电池15%到20%的，但是这个能量密度呢其实是相对较低。我们目前来看，未来市场主要的应用还是在一些偏中低端的一个新能源电池以及储能领域。而3元锂电池也在自身材料配比上去寻求一个更低成本的方式，就比如说采用高镍低钴的方式，因为钴本身是要比镍要贵一些，提升镍含量其实可以有效的降低成本，但目前其实主要的技术难题还是它的安全性会相对差一些。另外就是也有公司可能会采取直接就把钴就弃用了，就不包含钴的这种模式啊，就比如说现在这个国内的这个蜂巢能源。他们搭载这个蜂巢能源这种无钴电池的新能源车，其实在2021年已经发布了，它的安全可靠性其实也将随着这个产品的持续放量，也得到一个比较充分的验证。那除此之外，其实固态电池也是目前主流的一个发展和创新的方向，因为目前液态电池其实是没有办法完全去规避这种事故起火的可能性的，但是固态电池呢就可以比较完美的去解决这个问题，同时也将大幅度的提升能量密度。但目前固态电池大多还处于一个就是实验室阶段，或者说研发比较初期的阶段，成本啊、循环次数啊这些都还存在一些尚未解决的困难和问题，就是短期内可能对于它的大规模落地商用来看的话还比较困难。但是我们相信，随着技术的进一步的迭代发展，它未来可能会成为一个市场的主流。下一页，其实这里就是总结了一下我刚才讲到的一些核心的点，就不在这页多做停留了，我们可以翻到下一页。这页想重点介绍一下，因为这个其实是整个锂电池的一个产业链的情况。主要以中国市场为例，上游的原材料包括像钴、镍、锂、铜铂等等，然后它们经过加工制造，形成锂电池的这个核心的组件，这其中包括正负极材料、隔膜、电解液等等。基本上市场已经经过了比较充分的一个竞争啊，已经培育了较多的上市公司，市场集中度也比较高。我们这里看到，基本上这个 CR3啊、CR5啊都是在一个比较高的一个百分比上。这也促进了其实行业的一个规模化效应和成本的进一步下降。我们这里面这个饼状图吧，其实是展示了各个组件在电芯当中的整体成本当中的一个占比，正极材料占了42%，是最核心的组件。而我们其实比较熟悉的像宁德时代啊、国轩高科呀，这些都是电芯的生产商。那么电芯其实它，然后再到我们电动车上用的那种电池包，中间是还会经过一个就是封装的这么一个程序。那这一步呢就会增加，比如说会增加像 BMS 电池管理系统，还是一些模组，然后封装成不同的形态。那封装这一步其实整个上中下游都会有一些厂商去覆盖，有可能是电芯生产商自己来做这个封装。也有可能是第三方的独立厂商，那下游的车企也有可能会去做这件事，比如说比亚迪。那么我们也之前提到，其实性能的提升和成本的控制是动力电池行业的重中之重。 那么从产业链细分的角度，也做一下相关技术趋势的一个介绍啊。首先是正极，正极其实因为镍的价格相对比较高，那么高镍3元锂电池的渗透率是在提升的，就尽可能的降低这个钴的这个含量。以降低整体的成本啊。然后高镍电池的安全性和稳定性问题，目前还没有得到一个特别完美的解决，但目前是行业的一个趋势之一。另一方面就是通过这个结构创新与化工一体化去推动这个磷酸铁锂电池的增效降本。中低端市场磷酸铁锂电池它的成本优势还是非常显著的，然后性能其实随着现在一些技术的迭代和更新也已经显著的提升了，可以满足大部分场景的需求。你就比如说比亚迪，它就是完全不用3元锂电池，它是磷酸铁锂电池的一个坚定支持者。然后同时我们也可以看啊，国内的这个镍和钴的储量都非常的低，比较依赖进口。比如说中国的镍含量其实只占全球的3%，钴含量呢占1%。而且我们如果从数据上来看，全球已探明的钴储量也就是740万吨，但目前1年就要消耗掉10万吨。所以长期来看，这种原材料方面的供给不足的一个风险还是很大的。所以发展这个磷酸铁锂电池，去探索一些新的工艺手段，也比较符合这个供应链安全的一个考量。然后从负极层面上来讲，其实现在这个石墨负极的性能已经比较接近这个理论的值的上限了，所以现在也在做一些像这种硅碳负极做产业化的一些尝试。但当前也是面临了一定的技术难点吧，主要是解决这个体积膨胀的这个问题，是现在制约产业化的一个比较卡脖子的一个问题。然后第三就是隔膜，那隔膜它分这个湿法隔膜和干法隔膜，各自都有各自的应用场景啊。因为湿法隔膜其实它更适用于这种高能量密度的电池，目前在整体的占比当中其实是在逐步提升的。那么隔膜生产其实也非常依赖设备以及工艺本身。那么此前像这个我们说最头部的上市公司恩捷股份，其实就通过大量的收并购去扩充了自身的一个产能，也确立了行业领军者的地位。但后续新兴的一些企业呢，因为它包括去购买更最先进的设备，然后包括它工艺的一个迭代，其实在产品质量以及成本上也可能会形成一定的优势。所以说未来竞争呢，随着产能的持续放量也会逐渐加剧。电解液方面，电解液现在主要是这个锂盐上带一个革新吧，就是固态电解质拉开一个序幕，主要是因为现在还受到一个技术和成本双重的一个制约。不过如果我们从安全性的角度去考虑的话，就刚才其实也有介绍过，就只要是液态电解质，它就没有办法100%去杜绝这种起火的风险。那所以说去发展这种固态电解质也是一个确定性非常高的一个行业发展的方向。下一页其实就是我们刚才有讲到关于这个回收的问题啊，就是除了上面介绍的这个应用端，就是随着第一批动力电池达到设计使用寿命的一个时间节点吧，那么电池回收市场其实是一个不断扩大的这么一个趋势。那么左下角的市场增速图就可以看到啊，中国的动力电池回收市场从2020年的20万吨到25年就让增长到78万吨，那么平均的 CAGR 其实可以达到31%。那目前国内已经开始起草和讨论相关动力电池回收和再利用的一些指导性的文件。以目前的视角来看呢，锂电池的回收和梯次利用，市场当然目前还不健全，也存在诸多问题。就比如说这个成本上还算不太过来账。但可以预见的是，随着未来这个储能市场的快速放大，政策支持力度增强，而且像锂啊、包括镍啊、钴啊这些资源，它的紧缺度也会提升。那未来的这个回收市场的发展还是非常可期的。再下一页，这里其实主要是展示了动力电池回收的一个主要的流程。动力电池回收有2种途径，一种就是新能源汽车所有者将这个动力电池回收给服务网点，另外是新能源汽车整车报废之后，通过报废汽车拆解，再由新能源汽车生产企业进行回收。那这2种途径呢，最后都会导向就是废旧动力电池的梯次利用和再次利用的相关企业。整个过程需要新能源车企啊，然后消费者啊、回收企业以及国家多个政府职能部门的协同努力。就任何一个环节，就单一的这个角色是没有办法完成的。然后各个部门呢，也通过发展相关的这种政策，进行行业规范的一个制定和指导，同时去建立更为完整的信息系统。然后包括对于一些相关信息的一个登记和保存， 都是去完善整个这个流程和产业链必不可少的一些步骤。下一页其实主要是这个梯次及再生利用啊，我们其实主要就是要将这个，我们说在再生利用这块，主要是将废旧电池可以重复利用的部分进行拆解，再转化为可以在其他工业领域应用的这个材料，或者用来生产，比如说像储能啊、低速电动车呀这些对这个性能要求比较低的一些场景下的动力电池。那么在这种下，其实这种主要是通过像检测、分类、拆解、重组之后，然后转化为用于这个储能电站，然后低速电动车之类的这种电池呢，然后同时也可以通过一些像手动拆解、物理分离，然后再进行下一步的这个化学分离，中间比如说把一些像铝箔、铜箔、石墨、粉末等材料就进行进一步的分离了，然后这个原材料就可以进行一个重复的利用，然后那么这些原材料重复利用呢，就可以去促进整个动力电池行业的可持续发展啊，因为这些原材料很多也都是不可再生的嘛，然后存量是有限的。下一页。其实这个是根据整个这个研究机构测算，到2030年磷酸铁锂电池的梯次利用市场规模就将达到240亿元。从这个2020年计算，这个 CAGR 就是32%，还是很高的。尤其是2025年之后会迎来一个比较爆发式的增长。那右图其实展示的就是一条比较完整的动力电池回收产业链以及产业链不同环节的主要玩家。目前需要进一步构建的就是从动力电池厂商、新能源厂商到回收企业的这个整体的一个网络。这里面就列举了一个叫中国铁塔，其实就是整个电池回收行业的这个领导者之一。它已经与多个车企还有动力电池厂商达成了这种回收的协议。动力电池回收企业呢，其实将作为这个非常重要的一环，来实现动力电池的一个生产、利用、回收，然后再循环整体的这么一个产业链的闭环吧。那么在下一页。从主流的模式上，其实现在比较主流的还是就是重新的组装和组合电池模组的这种形式啊，就比较偏这种物理层面的一个处理。刚才也介绍，中国铁塔是核心客户之一嘛。那另外一种模式就是整包使用，在采购退役动力电池之后呢，就直接使用，不再拆散重组。那这种模式还停留在一个试点摸索阶段，主要原因还是由于这个电池包的生命周期啊，还有它的经济性啊，还未能判定。企业在使用寿命和维护成本方面，整体来说还比较谨慎。下一页是对于这个梯次利用啊，国内应用类的企业，这个像电信厂商、材料企业、新能源车企都有在布局相关的一些业务，我们这里也做了一个列举。那就比如说。中航锂电就将梯次利用电池应用于中国铁塔的通讯基站，宁德时代与宇通啊、上汽、北汽、吉利等车企就开展去合作回收废旧这个动力电池，将其改造用于储能。就是目前也当然也是属于一个探索阶段了，在技术还有商业模式上都还不太成熟。下一页主要是一个海外企业的一个相关情况啊，就这种案例和项目还是比较多的。就比如说德国的博世集团就利用宝马这个 Active-E 和 i3 的这个纯电动汽车退役的电池建造大型的光伏电站储能系统，并已经投入使用了。那么该系统呢由第三方这个瓦腾服公司负责日常的维护。那其他国家其实我们能看到也有应用在一些户用储能、工业储能等领域的一些尝试，就是大家都在探索这个相关的一些技术路径。再下一页其实就是关于这个材料回收的这个问题了。就刚才讲的还是梯次利用啊，这边是一个材料回收。那么整个这个回收市场预期是快速增长。那么3元电池刚才有介绍过，它的稳定性相对较弱，容量衰减比较快。相对于梯次利用呢？其实更合适去做一个核心材料的一个直接的拆解回收。那么从价值上看，这个锂、镍和钴是主要的一个回收市场。到2030年，这个市场规模就将达到565亿元人民币，整体 CAGR 可以达到45%。下一页其实也是技术层面了，就是电池与这个电池这种梯次利用的一些物理方法不同，那这种材料回收主要还是化学方法嘛。就包括像这个活法冶金、湿法冶金、生物冶金等等。那活法冶金其实就是顾名思义，就是通过这个高温焚烧分解的方式进行分解。那湿法冶金呢，则是通过先化学沉淀，然后之后再通过化学萃取的方式进行分解提炼。 而生物液晶呢，就是通过微生物来进行转化并选择性的溶解。那3种方法其实都有各自的优劣势，我们这里也都有做了一个列举。如果大家对技术细节感兴趣的话呢，会后也可以再详细了解和阅读一下啊。下一页其实是从我们投资人的角度上来看，其实目前市场竞争者主要是一个上市公司，包括宁德时代、格林美等等，两者的合计市场占有率就接近了50%，剩下50%被 Tier 2梯队的一个厂商瓜分。当前白名单企业共计差不多是27家，其次市场上还有很多黑作坊。就这一类现在来看呢，整个市场竞争环境对初创企业其实不太友好。一方面就是龙头企业像宁德时代啊、格林美已经形成了一个产业闭环，然后来降低成本，并进一步的扩大规模嘛，发挥这种规模化效应。其次就是第2梯队市场面对这个黑作坊，他们抬价就导致难以提升规模化效应来实现盈利。但是我们相信呢，就是随着政策法规的推行和完善，基于该市场规模的这个发展潜力，具备核心技术能力的一些初创企业，还是有这个关注和布局的机会的。尤其是他们要解决就是这个成本啊、污染、回收率等核心问题来做的这个技术迭代。对，这个是这一方面的问题。然后后面几页其实更多的是一些列举性的，也是这些主要公司的一个大概的情况。首先下一页是国内就是领先的这种锂离子动力电池回收企业，他们的一些业务情况和技术情况，这个可以翻到下一页。对，这边我们其实做了一个列举啊，比如说这里边宁德时代啊、比亚迪啊、中航锂电，我们看到这些顶尖的这个锂电池电芯的生产厂商都有去做这个相关的一些布局。对，然后下一页是海外。就是海外其实也有很多布局这一领域的优秀企业，那么采取的技术手段呢也都不太相同。就目前来看，其实尚未形成就是说哪一种才是最统一的一个最优方式，主要还是各个企业根据自身的一个优势和经验积累来做的一个选择和探索。后面2页啊，其实后面2页 PPT 都是就是各公司工艺的一个总结，还有一个回收规模的一个总结啊。就是这个的话，我就不再讲太多细节了。就是大家如果感兴趣，可以大概去看一下。就后面2页都是这个情况，应该一个是这个国内的，一个是国外的。对，就是大家可以简单看一下。然后重点讲一下最后1页了。就最后呢，我们还是想把这个行业拆分开来看啊，就是从我们投资人的角度，它整个像这个核心组件，比如说这个隔膜、铜箔领域，能够在工艺制造管理上形成独特优势，并与下游客户充分绑定的公司，其实还是具备一定的这个投资价值的。而从动力电池领域，则需要重点去关注的呢，是这种技术的迭代和演进。不管是我们现在像宁德时代主推的这个钠离子电池，还是说现在最备受关注的固态电池，都从某些方面解决了当前这个液态锂电池存在的一些问题。当然也都处于一个技术探索和研发的阶段，我们需要去关注这种潜在的被投企业它的一个技术特色以及整体行业发展的这么一个趋势。那同时这个储能赛道呢，其实也是充满机遇的。但是怎么说呢？就是能源行业啊，就不管它是新能源还是旧能源，只要是能源行业，其实永远是一个纯性价比的行业。就是我们就是前些年光伏产业链里面，像这个多晶硅和单晶硅之间的这个竞争，其实成本上可能就是几分钱的差距，但是到最后到终端就是100%和0的差距，就没有一个折中的选项。所以说呢，如何提升安全性、降低成本，其实是需要各个环节的一个优化配合，就不管是技术上还是管理上。当然，就是刚才也其实花了很大的篇幅去讲，就是随着现在存量市场逐步在做一个退役，那么电池的回收和梯次利用会是一个逐步放大的这么一个主题。当然现在目前回收体系还不健全，也存在经济性的问题，但我们相信未来随着政策支持，然后锂资源紧缺的这么一个情况，那未来的市场还是非常可期的。当然，刚才我后面在对储能行业以及其实这个新能源汽车结合比较紧密的这个智能驾驶行业吧，也做一个补充的一个介绍和交流。一个是，其实截止2021年底，中国已投运的电力储能项目累计装机规模就已经达到了46 GW，占全球总规模的22%，同比增长30%。 那截止2021年呢，其实抽水储能的累计装机量是最大的，差不多在39.8 吉瓦，同比增长25%。但其实市场增量，如果我们不看存量，看增量的话，它主要还是来自锂电池为代表的这种新型储能，也就是我们所谓的这个电化学储能。它的累计装机量规模达到了5.7 吉瓦，同比增长75%。这个原因其实很好理解啊，就是抽水储能呢，它其实就是对场地的需求比较大，因为它需要有一个落差嘛，然后同时还要有水在那儿，所以它灵活性是比较差的。而电化学储能呢，就是电池这种，它的反应速度比较快，调节能力也比较强，同时环境适应力比较强，在哪儿都能建，同时也能够进行这种小型的分散的配置，建设周期比较短，所以未来的发展前景是非常巨大的。就目前来看，锂电池的储能成本其实主要受制于上游这个碳酸锂这个原材料的一个价格。那这一点上，其实钠离子电池是拥有一个很大的潜在优势的，因为虽然当前钠离子电池它的成本还没有说完全的降下来，但是其实未来如果我们做一个测算的话，它是有这个潜力降低到差不多1元每瓦时的这么一个水平。那这一成本甚至是要比抽水储能还要再低。就另一方面，其实这里想补充讲的就是关于这个智能驾驶。虽然这不是新能源直接相关的，但是因为它其实是伴随着新能源汽车的发展，然后得到了一个飞速发展。那其实主要也是因为这个新能源汽车呀，它颠覆了传统汽车的这个动力结构，然后对整个智能驾驶的这个规控的执行啊是更加友好。同时呢，其实现在新能源汽车的利润空间比较紧张，所以非常需要额外的软件收入来增厚利润。那么主流的车企，我们就以这个特斯拉为代表，其实都在这一方面去重点发力。当然，其实因为特斯拉它本身的自己的研发能力比较强，用的是完全自研的一套体系啊，包括芯片。国内的车企其实更多的呢，还是在和第三方的一些包括算法厂商，包括一些硬件厂商进行一个合作，优先先去落地这个我们所谓的 L1、L2 级别的这种辅助驾驶的一些功能。那 L3 级以上的这个智能驾驶啊，其实它最大的一个阻力就是说，一旦到了 L3 级别，那么一旦出现了这种交通事故，它在法律的这个责任认定上就要有一个新的法律上的定义，所以是需要整体一个比较成熟的法规来去支撑的。这个国内暂时还没有这方面的一个相关的一个法律。同时就是说，现在 L3 级别的这个算法也没有完全的成熟，还处于一个测试啊、迭代的这么一个阶段。而 L4 及以上其实更存在一个非常大的一个不确定性。但是我们可以看到，其实国内外有众多的这个创业者呀，包括技术人员啊，包括资本，其实都有大力的在去支持，就是在去支持这个行业。这其中呢，其实一定会存在失败啊，也会付出很大的一个成本。但是呢，我们可以预想到，就是如果完全意义这种 L4 及 L5 级别的这种智能驾驶完全成熟意义的落地之后，其实对于交通环境，对于我们的这个出行的体验，包括整体的运营成本，还有包括能源的消耗，都将会是一个非常颠覆性的改善。就是我们也作为投资人啊，非常愿意去期待这一天的到来。以上就是我今天介绍的一个主要内容吧。谢谢大家的时间。
Thank you, Mr. Lee. So our next guest is Chen. Mr. Chen is the R&D director at a long-hedge company. His PhD in the physics from Arctic University of Norway. From the 2007 to 2012, he works as an engineer and a researcher in Renewable Energy Corporation, ASA, in Norway. After that, he started pushing his PhD as a researcher at the Scientific Research Institute in Norway. Since the end of 2016, he has been responsible for R&D at Start-Owner New Energy Institute and Lyon Batteries companies. He has profound knowledge and experiences in the materials, electrochemistry, and new energy. His current research interests mainly include Lyon batteries, all solid-state batteries, and new materials. Thank you. So welcome, Mr. Chen.
主持人你好，可以听得到吗？
Yes. 可以。
Hello, good afternoon, everyone. My name is Zhonghua Chen, and I'm honored to be invited to introduce our company and products. I am from Longtech. It was well known as FP Tech, and we are a lithium-ion battery manufacturer in China. Here is the contents I'm going to talk about. First of all, I will give you a brief introduction of Longtech and our history. Secondly, I will introduce our cell products and then tech products. In the end, I will talk a little about our advantages as a valuable lithium-ion battery supplier. First, about us. Our core team members started their battery business in 1999. That was manufacturing nickel metal hybrid battery. Now we have 3 manufacturing bases in China. All are located in Dongguan and Shenzhen, southern China, close to Hong Kong. Now, in total, we have over 1,200 employees. This is a sketch of our history. As I introduced, our core team members started their battery production in 1999. The battery factory was established in Jiangxi province. Our lithium-ion battery manufacturing base was founded in 2006 in Shenzhen, producing lithium cobalt oxide battery for cameras, cell phones, notebooks, etc. In 2008, we got certified by ISO 9001 quality management system and the 3C, UL, ROS, and the CE. In 2015, we established the production line for cylindrical lithium iron phosphate cell, model 32700. At the first years, 32700 cells was used only for large electrical vehicles like truck, bus, and now it's mainly used for low-speed electrical vehicles and energy storage systems. In 2021, Longtech achieved an annual revenue of over 1 billion RMB. So the second is cell products. Cylindrical lithium iron phosphate cells are our main products, including 32, 700, 26, 650, 18, 650, 14, 43, 0. Among them, 32, 700 is the main product. As you probably know, 32 is the cell diameter, and the 70 is the length of cell, and 0 means it's cylindrical cells. So the naming method is same for other cylindrical cells. For these cylindrical cells, we have low temperature model and also long cycle life model, which can be used at low temperature minus 20 degrees, and also long cycle life model, which has a cycle life over 3,000 cycles. We also produce prismatic lithium iron phosphate cells. What we have now is 22, 70, 160. 22 is the width, 70 is the width, is the length, and 160 is the height. 20 ampere hours, and also 40, 130, 205, 100 ampere hour. Others, like 50, 150, and 200 ampere-hour models are under developing. For 2070, 160 cells, the low temperature model can be used at -40 degrees. Except for lithium-ion cells, we also produce nickel-metal hybrid cells, including ACDF series. For lithium-iron phosphate cells, including cylindric and prismatic, the throughput in 2021 was 2 gigawatt-hour. Cells we supply have a high performance uniformity, and our prismatic lithium-iron phosphate cells obtain a long cycle life up to 3,500 cycles, which means after charge and discharge process for 3,500 tons, the discharge capacity is not below 80% of the original capacity. Cycle life mentioned in the following means the same. Here is the performance of our 3700 5.3 ampere-hour model cell. It has an excellent high rate performance. Under the condition of 3C charge and 3C discharge, the cycle life is over 1,500 cycles. The model of cell has also a good low temperature performance. When discharged at -20 degrees with a cutoff voltage 2.2 watts, the discharged capacity is over 55%. It has also a long cycle life. Under the condition of 1C discharge and 1C charge, the cycle life is over 3,000 cycles. We have also 32706 ampere-hour model cell. Its performance is outstanding. The cycle life at 1C charge and 1C discharge is over 2,000 cycles at 25 degrees. When discharged at -20 degrees with a cutoff voltage, the discharged capacity is over 65%. And also it has a high rate of performance for 3C charge and 3C discharge. The capacity retention is about 98%. We have also another model for high temperature. Its cycle life at 1C and charge and 1C discharge is over 3,000 cycles, compared to only 2,000 cycles for normal mode. And its cycle life at 55 degrees is 2,000 cycles. It has high rate performance, and also for 3C charge and 3C discharge, the capacity retention is about 98%. Our cells have been sold to many countries. For example, USA, Europe, Southeast Asia, Africa, India. They have been used in the following applications. First is power systems for low-speed electrical vehicle. For example, golf cart vehicles with 2 and 3 wheels, scooter, forklift, etc. And it's also been used for outdoor power supply. They have been using for camping, long distance driving, mobile office, store lighting, and emergency repair and rescue. So another application is for energy storage system. For example, household and energy storage system and the electricity backup. Our cells have also been used for small energy storage systems. For example, solar light, emergency lights for T-box, and the start power system on vehicles. The application also includes large energy system for grid, distributed PV power station, wind power station, and the industrial use. Before, we were very engaged in 3C electronic devices market. Now, our cells mostly are used for energy storage and the power system, though there is still partly used to electronic devices like computers, cell phones, cameras, and electric toys and tools. And the third part I will introduce is our pack products. Our pack production line has a capacity of 500 megawatts per year. It's equipped with advanced automatic process equipment and high precision classification facilities for sorting and matching to ensure high consistency of capacity, internal resistance, and voltage for each battery module. Here are some pictures of our pack facilities. In the lower left corner picture is a new automatic production line installed with mesh system. And this is one of our hot cell products, 48-watt series batteries. They can provide reliable backup power for accessing network equipment, remote switch, mobile communications, transmission equipment, and other systems. This series battery has a nominal voltage of 48 watts, nominal capacity from 10 ampere hour to 100 ampere hour. Nominal energy is up to 5 kilowatt hour for each module. And for higher energy storage system, the modules can be connected like this. This electric cabinet contains 30 kilowatt hour. Another popular battery product is 12-watt series batteries. They are designed to fit into the footprint of a standard lead-acid battery for replacing lead-acid batteries in these applications, like stop-start power supply for vehicles, golf cart, Segway, scooter, low-speed electrical vehicles for short-distance transportation. The nominal voltage is 12 watts, and nominal capacity is from 12 ampere hour to 200. Okay, in the end, I will give you an overview about our advantages. First, we are the biggest manufacturer of 32-700 cells in China, and it's well known that the performance and the quality of 32-700 cells are the best. Second, we have both cell and pack production line and can provide better quality and a higher performance price ratio. Third, we have an excellent research and development platform, which I will show you in the next slide. Fourth, Our core technology team members have been working in battery industry for 20 years. We have excellent R&D platform, including button cell lab and cell pilot line. And also we can perform lithium-ion battery related physical and chemistry analysis, electrical performance test, safety test, environmental adaptability test, and also pack performance test. Our lithium-ion battery engineering research center is provincially recognized. We have over 130 employees in the R&D development team. We are collaborating with well-known universities and institutes, and also cooperate with up and downstream companies to develop new technology and improve our products. Here are some demonstration pictures of automatic production line and automatic injection technology, and also online monitoring systems. This online monitoring equipment is X-ray for detecting the winding alignment, which is one of key parameters to self-discharge. Each cell is detected during the production. And our products have been exported to USA, Europe, and these countries and areas. And also our battery quality is recognized internationally. These are our well-known customers. Huawei, ABB, and also now the outdoor power supply, Power Oak. Okay, thank you for listening.
I hear you. So you want to start your speech before my introduction to.
Right.
Okay. So let me finish my introduction. Mr. Rada plans coordinate and implement ECOSF's research programs, notably in the area of global environmental change, with a particular focus on the sustainable energy, water, and climate change. Previously, Mr. Rada has worked with the World Bank, UNTB, and planning commissions of Pakistan on the way to strategy programs, including renewable energy, energy planning, electric mobilities, and sustainable energy for all. Okay, so welcome, Mr. Rada, giving his speech to us.
Thank you, Anne. Thank you, Dr. D. We are very pleased to be, joining this as a partner of the BTBU Research Joint Training Center. I think majority of the speakers who have earlier presented their insights and brilliant presentations on the subject. I think they've covered the overall global market and the how China can help the BRI countries, including the ECO member countries, in scaling up the lithium-ion battery market in terms of accessing or securing the raw material supplies from battery, from refinement of the chemicals to cell manufacturing, and then battery assembly, and to the final applications of lithium-ion battery market. So the idea of or the purpose of my presentation is to demonstrate that how the ECO region, the Economic Cooperation Organization, with its 10 member countries of Iran, Pakistan, Turkey, and Central Asian member states, including Tajikistan, Azerbaijan, Kazakhstan, Kyrgyz Republic, Uzbekistan, Turkmenistan, and including Afghanistan. So how is the market evolving in terms of lithium market? Next, please. So I think if you look at the application side, there's a tremendous potential in terms of the momentum that's or the traction that is increasing substantially for two main applications. Number one is the lithium-ion battery for the renewables and electric vehicles. And here in this transition, the electric vehicles dominate the battery market specifically for the lithium-ion in the region. So that's in order, if we want to have achieve substantial number of penetration of electric vehicles, lithium-ion batteries are the key to this EV transition. And third is that there's a wave of storage applications for lithium-ion batteries, but as we have understood that the role of most of the ECO member countries is quite limited in terms of local production and manufacturing of the primary lithium-ion cells. So what happens is that most of the ECO member countries do not produce or manufacture the primary lithium-ion cells. Of course, they procure or import lithium-ion cells from elsewhere. In majority of them, they have trade partners in China, Korea, Taiwan, Japan, etc. So this is the market where most of the imports are dependent on. So what happens is that imported lithium-ion batteries, once they land it in those countries, the imported cost of those batteries are too high, and that's is a challenge for high import bill in terms of expenditure. And this increases the transaction service cost, which is unsustainable for many energy and e-mobility applications. So that means that if the cost is too high, that would translate into low traction of EV mobility. So how do we address those challenges? It's going to be the main idea of this talk. So, but before I jump into assessing the market in this, so what are those policy measures that are driving the lithium-ion battery market in the region? So if you look at the policy measures, so there are various policy targets, for instance, zero emission vehicle targets, China, US, India, Europe, and Pakistan. So I've compared assessed this matter in terms of the policy, interventions. One is the zero emission vehicle target. It's the declaration of what percentage of the new cells would be EV dominant. And then there's the average vehicle fleet emission target. So that's measured in the gram of CO2 per kilometer. So if you look at the average vehicle fleet emission target and the fuel economy standard target, these are two measures that are at the regulatory level driving the original equipment manufacturers or the manufacturers or the assemblers of electric vehicles or conventional vehicles to switch to more efficient fuel efficient vehicles. And they have assigned some targets. If they do not, if the OEMs are not able to achieve those targets by a certain level during that period, they are heavily penalized. If I give an example, if the European target is to achieve 95 grams of CO2 per kilometer by 2021. If any manufacturer, whether it's Audi, Mercedes, any European OEM that's not able to achieve this target, they will have to pay $100 or 100 pounds or euros per gram by the time it's just exceeded, and you multiply it by the number of vehicles they produce in the entire year. So that's billions of dollars of the penalty they need to. So there are physical limits where they cannot exceed the performance of those internal combustion engine. So the most easiest path is to go or to switch to electric vehicles. And if they produce that vehicle which emits much less than that prescribed target, they earn targets and they can sell it to other OEMs. So there are both regulatory drivers and also the policy drivers that are driving the demand. And because of this, the electric vehicles demand is going up. And that demand is translating into substantial increase of the or the demand for the lithium-ion batteries and subsequently the raw material that goes into those. I think many of my colleagues earlier they talked about the demand, and it's quite evident that China holds the biggest share and dominates the EV market by by a scale in terms of it is the largest producer, largest user of electric vehicles. Thereafter it comes the United States market. Germany over the past 4 or 5 years have been ramping up its production quite heavily, and then there's a UK, Norway. These are the countries that are quite ahead in terms of the penetration target. So, what are the consequential impact of increasing demand for electric vehicles? It's that it has a significant impact on the raw materials that it supplies and it goes into the battery. So there are 4 critical metals that goes into lithium-ion batteries: cobalt, nickel, magnesium, and lithium. But for one example, I've just given you here an idea of how that lithium demand would catch up in terms of, or whether we would be able to achieve or meet those production targets of those vehicles. So this is a little graph that at the upper half of the screen is the lithium demand versus the finance and unfunded supply. So you see that the yellow is an operational supply that's already available right now, and in the blue is in construction. The lighter blue is the unfinanced projects, and the red ones are the recycled supply. So as you could see that right now the market for recycled is not as much, and then there are a lot of projects, gigafactories that are in production and in construction. So what you can see is that even if you are able to ramp up the production of those, or the manufacturing facilities of lithium and battery markets, you would still need an additional supply of the raw materials to go into to meet the required demand. And on the lower bottom, or half of it that you see is the export. On the right side is the imports, and on the left side is the export. So you see that majority of the raw material for lithium is is sourced from Chile, Argentina, Bolivia, and some part of Belgium and China, and that goes. So that's exported to, and the major importers are on the right hand side of the South Korea, China, and Japan. So you have a very limited footprint if you see that the ECO countries, the Iran, Pakistan, Turkey, and other Central Asian states, they have a very limited footprint in terms of what they produce for the raw material that goes into lithium-ion battery market. So this is the trade flow, the lithium-ion supply chain trade flow of the critical metals. As you see, there's cobalt, lithium, carbon, nickel, and magnesium. So in terms of lithium, so the red arrows at the end show that these are the exporting countries, and it turns into green. That means these are the importing countries. So if you see that in South America, there's Chile, Bolivia, Argentina, the lithium triangle. They export the lithium primarily through China and South Korea, and then again Australia has a pretty bigger role, and that goes into China. It's refined and made into refined product, and that's sold back to other European and American markets. Same is the case with the cobalt and manganese. So for cobalt, almost 50% of the share or the dominance is maintained by the Dominican Republic of Congo, and for manganese, it's the South Africa. Whereas these are for the critical metals. So one of the important metals that goes for the lithium-ion battery is the anode, which is predominantly used by or used in terms of the metal that goes into it is natural graphite. So Turkey holds the highest result of natural graphite in the world, which is a perfect anode material for lithium-ion battery. So this is where the role of an ECO member country is. And recently we have we've been told that, and there is a high degree of confidence that the lithium that's found in Afghanistan, which is crucial, crucial for the large-scale battery production. So the total valuation of the lithium that is believed to be deposited in terms of the reserves in Afghanistan, amounts to over $1 trillion or something. And there are several studies that have quoted. So right now, you do not see the ECO members' contribution as much, but I believe that with the recent political changes and the going forward, the partnership that we have established among the ECO member countries, particularly China, Pakistan, and Afghanistan, we might be able to see a pretty decent and solid role of Afghanistan that would play critical for establishment of the raw supply of raw material, and then establishment of the refining and cell manufacturing facility in the region. So this small circle you see, this is the footprint of the ECO region, Iran, Pakistan, Turkey, Central Asia, and Afghanistan. So in terms of if we have to fragment the lithium-ion battery market, first is the extraction. So extraction, as I said, that this is a geographic specific, and Pakistan or India, Iran or Afghanistan or other ECO member countries have a limited role right now, but we expect that Afghanistan would have a pretty decent role with the given the fact that they have a pretty large resources there. And for the chemical processing, this is the second fragment that is very important, because once you have extracted that material, how do you process it chemically? And this is where the China holds a dominance. About 80% of the chemical processing is done in China, and this is the expertise. This is what we would like to leverage in our partnership in bringing that knowledge resource to ECO countries, so that we were able to produce the cathode and anodes. This is the third fragment. And the fourth segment is, of course, the cell manufacturing. So if you look at the current market, majority of those, except Turkey. So Turkey has recently established a cell manufacturing facility, but other than Turkey, majority of those, most of those ECO member countries are relying on battery pack assembly, where we procure, import those loose cylindrical cells or prismatic cells, and we stack them together and build the batteries for various applications, for majority for EVs and renewable energy backups. So among the ECO member countries, the biggest market for electric vehicles, of course, are Pakistan, Iran, and Turkey. One of my colleagues earlier presented some insights on the market outlook for the sales of vehicles in the Central Asia. So this is a slide that shows you how big is going to be the market for Pakistan. So currently, the total registered vehicles in Pakistan, at the bottom you see that there are over 22 million two-wheelers, the bikes, about 4 million cars and SUVs, about 1 million three wheels or rickshaw, what we say, and about 0.3 million trucks and 0.25 million buses. So this is the scale of, if we are on to electrify, because Pakistan has recently launched a policy to electrify the road transportation. And for that, and that target is that by 2030, about 50% of the road vehicles, primarily the two wheels and the bikes and the car, the sedan vehicles, and in fact, the three wheels would be electrified into e-mobility applications. So on the top of that, if you look at the left, it's the market penetration scenarios. So even if we go with the lowest conservative estimate, if things do not, evolve in a favorable condition, we might be able to see about 1.7 million electric vehicles on the road in Pakistan by 2030. But if we are very lucky, if the price of raw material goes down, if the battery cost goes down, and if there's a high penetration of EV vehicles, so there's an ecosystem, we might be able to see about 6 million of those vehicles and by 2030. And on the right, you see that what's the EV adoption inflection point. So which segment of that transport is commercially good enough right now so that it makes a commercial sense. For instance, the two-wheel electric and three-wheel auto rickshaw, they've already achieved the inflection point. By inflection point means that the purchase cost of a two-wheel electric versus conventional has not reached yet, but if we take into account the cost of fuel, so it makes perfect sense to switch to an EV because it saves a lot of money in terms of fuel. So there is a commercial feasibility that have already achieved. So what we expect is that by four-wheel, we still need some time, maybe about a couple of years, till that the battery price come down. And for commercial vehicles, there are some bottlenecks. So for the retail car, this is going to get the maximum amount of time and duration so that we are able to achieve that the inflection point by about 2027. So this sums up the last slide. So the two wheels, rickshaws, and commercial vehicles, they've already, so two wheels and rickshaw, they've already achieved that inflection point. These are the easiest to electrify for. So among these, segments in the region, regardless of the country, these commercial vehicles and the two wheels would be easier to electrify, and they've already achieved the inflection point. The retail cars would be the last ones to be electrified based on the commercial feasibility, because commercial vehicle, the commercial feasibility of an EV is enhanced by the fact that the number of miles you run. So the higher the number of miles you run on your vehicle, the higher the commercial attractivity you can. I think this is a slide that has been discussed quite widely by my previous 3 or 4 colleagues. So and globally the price has been coming down quite significantly. If you just imagine that the price of a kilowatt hour, battery, $1 per kilowatt hour terms, it used to be over $1,100, and now we stand at about $120 in 2022. So that's a quite significant decrease. About on average is about 20% each year, and a lot of industry experts believe that this trend will continue. And earlier I mentioned about the role of China in that in the entire market, and this is the supply of raw material. So China dominates. So from upstream mining, China has only 23% stacks, but from midstream, in terms of chemicals refining or cathode, anode, and then downstream lithium-ion battery cells, China holds a major share of that. So that's why we're quite optimistic, given the fact that we have pretty robust linkages with China, and as part of the Belt and Road, we expect that this cooperation in the lithium-ion battery market will further enhance, and we'll be able to develop our own capacity with the help of China. So at the moment, the total annual production capacity of the battery is 10 to 50 gigawatt hours. That is going to go and increase to about 3,000 gigawatt hours. In terms of the market valuation in Pakistan, today it's only about 0.6 gigawatt hours. But what we believe is that by 2030, the market going to be able, it's going to reach about over billions of dollars, about 5 or 3. Even if we can consider the estimate of 5 million EVs, it's a substantial market. So the immediate solution for the countries in the issue is that we want to establish a semi-automatic assembly line where we import cells and assembly, build our own battery packs and sell it to the local market. So, and what factors would depend, or what factors would influence further in terms of scaling up the electric mobility market? It's again the policy, the battery price. So the battery price is the one of the most important factor in scaling up the e-market, market. For a policy that they are mandated target, if the battery price stands at about $150 or something, the traction would be low because the affordability element that comes in. But if it stands at $150, the battery cost would translate into higher cost of an electric vehicle that would not be affordable by large segment of the consumer market, and that's why the traction is low. But if we are able to achieve a battery price of less than $100 something, that would be a tipping point where the price of an electric vehicle would coincide with the price of an internal combustion engine. So the idea or the purpose was to understand what issue market can gain from the global supply chain line. So the first thing that we understand that today we have a very limited role in terms of we do not produce raw material. It's a pretty non-existent. Then we do not have any role in chemical refining, cathode, anode production, and finally in cell manufacturing, we still have very limited role. So what would we do? Predominant practices that we import cells and assemble into battery packs and sell. So the idea is that we need to have and establish a robust strategy for localizing the electric vehicle or the lithium-ion battery market for EV supply chain. It's and not just limited to EV, battery, but other parts of the electric vehicle as well. So the key thing here in terms of accessing the raw material is that we need to supply key raw materials of the metals that we have discussed quite at length, and leverage our existing partnership with China to establish manufacturing facilities in the Belt and Road in the ECO region, develop local and mining capacity in the ECO member countries, particularly with reference to Afghanistan, that we believe that there are substantial mineral resource for lithium and other critical metals that would be quite a game changer for the region, and also achieve solid partnership with the Chinese partnership enterprises to build the capacity in chemical refining and cell manufacturing, etc. So 3 takeaways. Short term, we install the battery assembly and manufacturing facility in the ECO country. The medium term is to invest into cell manufacturing facility. And the last, that's long term, that's invest into local mining, that's chemical refining capacity in the region. Thank you, that's all. Professor Devi there? Sir. Right.
Thank you, Mr. Raza. Okay, at the end, let's invite dear Professor Syed Komal Hayati to deliver a closing speech. Welcome.
Okay. Okay. Distinguished participants, colleagues, ladies and gentlemen, good afternoon to you all. It gives me an immense pleasure to congratulate you all that the 6th joint training program of BTBU-ECOSF Joint Training Center entitled Powering Belt and Road Lithium Batteries was held successfully, and it was quite fruitful. I would like to take this opportunity to share that since I have joined recently as the new president of the ECU Science Foundation, and thus this has been my first formal participation in this joint training program. And I am very pleased to interact with the Beijing technology and in this joint training program, and I'm very pleased to interact with the Beijing Technology and Business University team. Hence, I would like to extend my deep appreciation to the leadership of Beijing Technology and Business University, and especially Dr. Yuna, Director, BTBU-ECOSF Joint Training Center for their partnership and continuous support through this center to promote the low carbon development in the Belt and Road countries, including ECO member states. Ladies and gentlemen, we must recognize that science, engineering, technology, and innovation play an important role in providing policy instruments that are essential to develop a strong base of countries for boosting socio-economic growth and sustainable development. The Belt and Road Initiative of China commits to foster the industrial development with a strong technical cooperation in many fields, including sustainable energy, infrastructure development, emerging technologies, and smart cities of transport, etc. To achieve these massive goals, it requires a robust commitment to support science and engineering, including the capacity building and human resources development. However, in order to maximize the benefits of BRI, the participating countries need to establish and engage in an alliance for promotion of cross-border cooperation in the STI sectors. There is an outstanding demand and supply gap for engineering and technical workforce that is necessary for successful implementation of BRI, and in order to fill this gap, consolidated effort must be undertaken to develop effective collaboration on STI mechanisms and to leverage the limited resources to make significant impact. Undoubtedly, the Belt and Road Initiative is an ambitious effort to improve regional cooperation, and connectivity is the core determinant to this entire initiative. Thus, the Economic Cooperation Organization, ECO region, which includes 10 countries, Afghanistan, Azerbaijan, Iran, Kazakhstan, Kyrgyzstan, Pakistan, Tajikistan, Turkey, Turkmenistan, and Uzbekistan, being important part of BRI. Holds great potential as an important gateway to connect China with the Middle East, Southeast Asia, and Europe and beyond. Distinguished participants, we all do recognize that energy storage market is on rise across the world. Electrical engineering powers our lives, and with batteries, it can be accessed with ease and efficiency. Lithium battery is an extremely important technology which could play a significant role to achieve clean energy transition. With lithium batteries, the supply demand can be balanced over time in various sustained situations, even when no energy can be produced. We also recognize that the fact that China has now been the world's largest lithium battery consumer market for five consecutive years. Hence, realizing the importance of this topic, we are undertaking this training to bring China's extensive expertise and best practices to help guide investment to develop a regional lithium battery manufacturing value chain that creates equitable clean energy manufacturing jobs in the Belt and Road countries while mitigating climate change impacts. Ladies and gentlemen, ISIO Science and of Science Foundation, based in Islamabad, Pakistan, being nurtured by the government of Pakistan and Iran or other countries, is an intergovernmental organization and a specialized agency of the ISIO. We are mandated to promote scientific and technological research and education with an end goal to raise socio-economic standing of 10 member states and to pursue the end goal capacity building of the member countries is a key prerequisite. I am confident that this training on lithium batteries has been extremely valuable for our participants, and it will strengthen the exchange and cooperation between the Chinese green enterprises and participating BRI countries to explore investment and business expansion opportunities in the areas of renewable energy development, cleaner mobility solutions, and smart and resilient power grid operation as well. At the end, I thank you all for joining us, and I assure the partners that ISIO-SF will continue the cooperation and collaboration in the field of science, engineering, technology, and innovation for pursuing our common goals along the Belt and Road. Thank you for your attention.
Thank you, Professor Kayapi. So that's all the sixth training program of BTBU and ECOSF joint training centers. We hope to see you everyone in the next training program.
See you next time.
Bye-bye. See you. 完成，感恩。